chill from 93 till.
This is how we chill from 93 till.
This is how we chill from 93 till.
This is how we chill from 93 till.
Alrighty, so in this question we're asked to find the points where r of t equals sine t, cosine t, and sine t times cosine 2t intersects the xy plane. Okay, so what we have to do here is basically identify what they want us to find. So we're supposed to find some points where this thing intersects or crosses the xy plane. Okay, and it will do so only when, if we look at it graphically, I have no idea what this graph looks like, but let's say it looks something like squiggliness, like that. Okay, so what we're asked to find are these points here, where it's flat on the xy plane. Okay, not necessarily on the axes. Let's say it crosses the xy plane here too, but anything where it crosses the xy plane. Okay, so the key point to remember there is that when it crosses the xy plane, our z value is 0. So we're looking, when does z equal 0? When is z kind of like flattened to 0? So we're going to look at our z component, of course. So that's sine t cosine 2t. And then we're going to set that equal to 0. So we're going to find the t values at which this is true, this equality is true. And then we're going to go back and plug that t value into our r of t to actually find those points, those vector points. Okay? So let's find this out. So we have either sine t is equal to 0, or separately cosine 2t is equal to 0. Okay? So let's see. Sine of t equals 0 when we're at either 0, t equals 0 or pi. We won't go around and repeat 2 pi because that's the same point as 0. Okay, and then let's see for cosine. So that means that 2t is equal to pi over 2, 3 pi over 2, and we can continue a couple more, 5 pi over 2, and 7 pi over 2. Because when we divide these, when we get t, we're going to divide each of them by 2, so we have pi over 4, 3 pi over 4, 5 pi over 4, and finally 7 pi over 4, which are definitely within the range of t goes from 0 up to 2 pi. We don't want to repeat anything, so we're just going on one cycle, one circle around, right? Okay, and these are all in one cycle. Okay, so now that we have our t values, we're going to keep all of these in mind, and we're basically just going to plug each one individually into our r of t, into our given parameterization. And I will continue to do so on the next slide. Okay, so just a reminder, our r of t is the following. So we have sine t, cosine of t, and then we have a sine t cosine 2t. All right. So first one, we're going to plug in t equals 0. Okay, so that'll be r of 0 is equal to sine of 0, cosine of 0, and sine 0 cosine 0. Okay, so this is going to be sine of 0 is just a 0, cosine of 0 is a 1, and sine of 0 is just a 0. So we have 0, 1, 0. That's a pretty easy point there. And then we have the next t value that we found was pi, so we'll plug that guy in. So we have r of pi is equal to, we're just going to keep repeating the same thing. We have 6 values in total to plug in. So we're going to know this inside and out, but that's completely fine. So then we have cosine 2 pi. Let's not forget there. This was a 2 times 0, but I just made it 0. Okay, so this is going to be equal to sine at pi is just a 0 again. Cosine at pi is a -1. And this, since we have a sine pi there, that's just going to be 0 overall. So look, we found 2 points already, and now for the last 4. So t equals pi over 4. We're going to plug that in. So r of pi over 4 is equal to sine pi over 4, cosine pi over 4, and then sine pi over 4 times cosine pi over 2, right? Because we had that pi over 4 times 2 is just pi over 2. Okay, so then what we're going to get from this is just going to be sine pi over 4 is positive radical 2 over 2. Cosine pi over 4 is the same thing, right? They're both positive. And then cosine pi over 2, that's just going to be 0, so the whole z component is going to be 0 on that one. So halfway done here, let's continue on. So we have t equals 3 pi over 4. So let's try this one. 3 pi over 4. This is going to equal sine 3 pi over 4, cosine 3 pi over 4, 3 pi over 4, and then sine 3 pi over 4, and cosine 3 pi over 2. All right, so sine 3 pi over 4 is the same thing, right? We're still above the x-axis, right? We're in the positive y's. And then cosine 3 pi over 4, though, that is a negative. That turns negative. That's on the left side, between 90 and 180, right? And then we also have, for cosine 3 pi over 2, that's also just a 0, okay? Because there's no x component there. So the next one we're going to try is t equals 5 pi over 4. So when we do this, we have 5 pi over 4, okay? And then what we plug in is sine 5 pi over 4, cosine of 5 pi over 4, and continuing sine 5 pi over 4, and cosine 5 pi over 2. Okay, so what is this? 5 pi over 4 is, it points down to the bottom left. And then, so this is going to be a negative radical 2 over 2, another negative radical 2 over 2, and then cosine 5 pi over 2 is kind of in the same place as cosine pi over 2, so that's also going to be a 0. All right, so last one, we made it, so we're going to plug in t equals 7 pi over 4, all right? So, as I said, last one here. Okay, we'll make this the best one, so sine 7 pi over 4, cosine 7 pi over 4, sine 7 pi over 4, sorry this is so long, and cosine 7 pi over 2. Okay, so this last point is going to be, so 7 pi over 4 is pointing down and to the right, so it's in the fourth quadrant, right? So our sign is going to be negative because it's down over 2, but our cosine is going to be positive, our x value is positive, and then for the last one we just get a 0 again because of the cosine 7 pi over 2. Okay, so we found our a total of 6 points here, and they're all the ones at the end. Okay, I'll just box them real quick so you guys can find those quickly there. All right, and that does it for that step. This is where, again, just as a refresher, because this problem was kind of long, it's kind of lengthy here. These are the points where our given parameterization, our graph, intersected the xy plane, which meant that our z value, or our z component at these points all equals 0. And as you can tell, they do all equal 0, right? All of our z components here equal 0. All right, so we're good. On to the next question.
Chilling 'cause my crew's close, kid. I posted,